In the last video, we figured out the problem. We need to teach a computer to detect feelings in text. But here's the first wall we hit. Computers don't understand words. They only understand numbers. So we need to turn text into numbers. The simplest way to do this is called bag of words. Here's how it works in 3 steps. Step 1. Look at every review and collect every unique word. That becomes your vocabulary. Step 2. For each review, count how many times each vocabulary word appears. Step 3. Now each review is a vector, a list of numbers. 1 number per word in the vocabulary. Let me show you an example. Say our vocabulary has 8 words. The class is great, exam, bad, loved, teacher. The review, the class is great, becomes 1, 1, 1, 1, 0, 0, 0, 0. Each position maps to a word. 1 means the word appeared. 0 means it didn't. Simple. But there's a huge problem. The word the gets a score of 1. And the word great also gets a score of 1. Same weight. But the is noise. It tells us nothing about sentiment. Great is the signal. It's the word that actually matters. And we're treating them the same. That's terrible. We need something smarter. Enter TF-IDF. It stands for Term Frequency times Inverse Document Frequency. Sounds complex, but the idea is simple and beautiful. The first part, term frequency, asks, how often does this word appear in this specific review? If the word great appears 3 times in a 6-word review, its term frequency is 0.5. The second part, inverse document frequency, asks, how rare is this word across all reviews? If the appears in 98 out of 100 reviews, it gets a tiny score of 0.02. But if great only appears in 12 out of 100 reviews, its score is 2.12. Much higher. Now here's the magic. Multiply them together. The scores 0.17 times 0.02, which equals 0.003. Practically 0. Crushed. Great scores 0.5 times 2.12, which equals 1.06. A high score. The meaningful word wins automatically. No human had to decide which words matter. The math figured it out on its own. TF-IDF boosts rare, meaningful words and crushes common noise. So now we've solved the first problem. We can take any sentence, turn it into a list of numbers, where important words have high values and filler words are close to 0. But these numbers still need something to process them, to look at them and make a decision. We need a brain, a neural network. That's what we'll build in the next video.